Okay, so which of the following is most reactive towards nucleophilic addition? So if we look at these molecules, we see we have an aldehyde, we have formaldehyde, we have a ketone, and we have another ketone. So let's go ahead and label these. So we have an aldehyde. And so formaldehyde is your simplest aldehyde, right? We don't even have any other carbon groups on there. We have a ketone, and we have another ketone. Okay, and so in the last example, we saw that where aldehydes and ketones fit in the general scope of carbonyl reactivity. So they are less reactive than your really reactive carboxylic acid derivatives, but more reactive than your less reactive ones. And so if you're comparing an aldehyde and ketone, the things that we need to consider are electronics and sterics. Okay, so we're looking at towards nucleophilic addition. So what that means is we're looking at the carbonyl carbon as being an electrophile. So partially positive and this being partially negative. So what would happen if we have a nucleophile, so let's just put a generic nucleophile. So we're talking about this nucleophile reacting with the carbonyl carbon and pushing electrons up onto that carbonyl oxygen. Okay, so for electronics, electron donating groups would make the carbonyl less reactive. So let's just build off of this. So electron donating groups decrease electrophilicity. Okay. And in terms of sterics, we're just going to say that larger groups block the nucleophilic attack, or just block the nucleophile. So in that case, it would be less reactive. So in terms of electronic effects, the first thing we want to recognize is the difference between the reactivity of an aldehyde and a ketone. And so the general trend that we say is that aldehydes are more reactive than ketones. And this is because your ketones have 2 electron donating groups. So those R groups are these are weakly electron donating. And so if you're wondering why they are electron donating at all, you want to think back to what we talked about with carbocation stability way back in the first semester course, that the more substituted carbocations are more stable because the bonds to carbon help donate electrons. And so they're weakly donating through something called hyperconjugation. Okay. All right, and so that's what makes our ketones less reactive than our aldehydes, because on your aldehyde, you only have one of those groups, and the other side you have a hydrogen, and hydrogens are not electron donating, okay? And there's also a steric effect as well, because this hydrogen here is small. So this is small and not electron donating. Right, so if having just one hydrogen on there makes it more reactive, having 2, like you do with formaldehyde, makes it even more reactive. And that's because of both of these factors. Now, you don't have any electron donating groups, and you've got 2 really small atoms. So this formaldehyde is your most reactive. Okay, so this would be the most reactive out of this trend. So on this trend here, we are just looking at aldehydes and ketones. So formaldehyde would be your most reactive. So one of these 2 ketones would be your least reactive. They both got the same number of electron donating groups, so sterics will come into play here. And this ketone with this increased branching rate next door to the carbonyl, that would actually be your least reactive. So for 2 reasons, because it is a ketone and because of sterics.